We're going to take a look at the use of the quadratic formula in a number of examples. The first example here, x squared plus 10x plus 25 equals 0. And we could solve this by factoring. So if we factor, it becomes x plus 5 whole thing parentheses squared is equal to 0. And you can see then that the solution is that x is equal to a negative 5. So it's solved fairly quickly by factoring, but if we solve it by the quadratic equation, we can see something interesting. So we'll go to the equation negative b plus or minus square root of b squared minus 4ac whole thing divided by 2a. And plugging in the coefficients here, we've got 1 and 10 and positive 25. We've got negative b is negative 10 plus or minus square root of b squared, so that's going to be 10 squared, which is 100, minus 4 times 1 times 25, whole thing divided by 2 times 1. So we get here a negative 10 plus or minus square root of 100 minus 100 gives us 0. And so dividing by 2, we end up with adding or subtracting 0, which gives us the same thing. And we get that negative 10 over 2 is the single solution, which is equal to negative 5, the same as we got before. The thing to observe here is that we do get one solution because the interior of this radical, the discriminant, is equal to 0, giving us two solutions that are identical. Let's move on to this example. So again, we're going to use the quadratic formula, and our coefficients here are positive 1, negative 2, and positive 7. So plugging into the formula, we get negative 2 is a positive 2, plus or minus square root of b squared, so negative 2 squared is 4, minus 4 times a, which is 1, times c, which is 7, whole thing divided by 2 times 1. So we get a positive 2 over here, plus or minus square root of, and then the second term, 4 times 7 gives us 28, but this is subtracted. So 4 minus 28 gives us square root of a negative 24. And that's going to give us an imaginary number. So for now, I'm going to separate the two terms here so that we can divide by 2 individually. So we got 2 over 2 plus or minus. And now this radical I'm going to simplify. So the negative 1 inside becomes an I when we take the square root of that. And the perfect square part, I can bring out a square root of 4 and I'm left with square root of 6, whole thing divided by 2. And this square root 4 becomes a 2, and so these will cancel here, and we also cancel out the 2's from the first term. And so we're left finally with positive 1 plus or minus I times the square root of 6. So notice this time that we ended up with two solutions. These are different solutions, but they're both imaginary, and that came about because the interior of the radical, which again we call the discriminant, was negative. Now let's take a look at one more example. So here we've got x squared, so our coefficient a is equal to 1, our coefficient b is equal to positive 5, and our coefficient c is equal to positive 1. Plugging into the quadratic equation, we get negative 5 plus or minus square root of b squared, so 5 squared is 25, minus 4 times 1 times 1. Whole thing divided by 2a, so that's going to be 2 times a positive 1. So simplifying this, we end up with a negative 5 plus or minus square root of, and then 25 minus 4 gives us a positive 21, whole thing divided by 2. This time we have a positive number inside the radical, and so this tells us that we have real solutions and there are two separate solutions. And now let's actually find decimal values that approximate these solutions. So realizing that the radical is an irrational number and is a non-repeating, non-terminating decimal, but we can take that square root and we get that this is approximately equal to 4.58. And if I round to one more digit, I get a 3 here, but I'm eventually going to be rounding to the nearest hundredth. So my first solution is going to be found by adding the radical. So I've got negative 5 plus that value of 4.58, 3 divided by 2. And now rounding to the nearest hundredth, I get a negative 0.21. And now going on to the second solution, I can take that negative 5 and subtract. So I've got negative 5 minus 4.583. And that's going to give me something pretty close to negative 10. Then divided by 2 is going to give me a negative 4.79. Again, rounding to the nearest hundredth. So we see the three different examples, the interior of the radical being a 0, being a negative, and being a positive, and we can see the different results in solutions, a single solution, 2 imaginary solutions, or 2 real solutions. And in the last case, we actually found decimal approximations for these 2 real numbers.